Welcome to the 14th webinar session for Coffee with Coral. In this video, we talk to JSF Technologies about Lumiwalk, their brand new illuminated crosswalk system. All right, let's join the session. And again, thanks for watching.
Appreciate that, Ryan. Thank you, everybody. Welcome to another session of Coffee with Coral. Again, our focus today is going to be on the Lumiwalk products by JSF Technologies. As Ryan mentioned, my name is Rowan Claxton. I look after more of the business development, sales, and product training here at JSF. For those of you who might not be all that familiar with our company, we manufacture solar LED roadway equipment. So that would include 24/7 flashers, crosswalk lights, school zone systems, and now area lighting equipment that we've got integrated with our crosswalk system. So I'm going to share my screen and I'm going to walk you through a slide pack that's going to cover some information on the Lumiwalk system. So right now, Ryan, can you see me on video?
Yeah, I see you there. I see you on video.
Wonderful.
Sorry, I had to find my unmute button.
Weird. So after we go through the slide pack, I will turn on the systems behind me so that everybody watching can have a look. So I will share the screen here. Tell me when you can see Lumiwalk.
Yes, we can.
It worked that easily. Okay, Lumiwalk, crosswalk beacons and illumination. So what we're going to talk about is effectively what is the Lumiwalk. It's an interesting name that we've come up with, and so we'll cover exactly what it is, some of the various Lumiwalk applications. We'll talk specifically about the LED fixture or fixtures that we can use, some of the basic system configurations, take you roughly through a product range breakdown to show you some of the main sizes. We'll talk about the lighting calcs and photometrics, the core Lumiwalk checklist, and then of course we'll open it up to questions. And likely as most of the Coffee with Corals have done, we'll keep this fairly informal. If you guys do have questions, you're welcome to chime in, but there also will be a Q&A towards the end, okay? So, Lumiwalk crosswalk lighting systems, and there's an example in the upper right of a photometric 3D study that we've done, which I'll touch on a little bit later on. So, what is the Lumiwalk? Well, effectively, simply means an illuminated crosswalk. So what we've done at JSF is we combined crosswalk area lighting or flood lighting with our standard flashing beacons or our RFBs or light bulbs. So what this is doing is this is creating a far more effective solution to improve pedestrian safety at a crosswalk. Anytime you're making a pedestrian more conspicuous, more apparent, more obvious, you're going to save lives. So whether your goal is to increase the driver awareness of approaching crosswalks or simply make people more visible, we can help you with that type of product, with the Lumiwalk specifically. And here's some good data that was put out by the FHWA in 2010, just showing the benefits of not only putting flashing crosswalk systems to increase driver yield rates, but just showing you how many pedestrian deaths actually occur in the dark at non-intersections. Okay, so this information really does prove that it is far more, it's a far better solution to have proper illumination, not just flashing crosswalk beacons or RFBs, but also full floodlighting illumination at every crosswalk where applicable. So some of the basic configurations, applications. I should first mention that these products are fully compliant with NUTCD and IES requirements. And I'm going to talk about IES a little bit later on. And that's a term that you'll hear if you're ever involved in area lighting or the lighting industry in North America, or actually globally. IES is the Illuminating Engineering Society, and they are, think of them as a governing body that give recommendations for light levels for any application you can think of. So our products follow not just NUTCD for the roadway splashers, beacons, and RFBs, but we also follow all the IES guidelines for a crosswalk application. So we can use these systems. As an example, this diagram here shows you a typical example with our 9400 series, which is our dual flashing, whoops, sorry, I jumped ahead. Our dual flashing light bars. But as it mentions here, we can do one round, we can do dual round, triple round, we can do 4 round beacons. We can do just about any configuration here that the end user might like to see. So a typical setup is going to have push button that's going to turn on the lighting systems here per every activation, as well as it's going to turn on a flood lighting system here only for the duration that these are running as well. So that's a 20 or 30-second duration typically. So what you're doing now, instead of just letting the traffic know that there's a crosswalk and there's somebody crossing, you're actually lighting up the entire crosswalk with 2 of these systems, one on the each side of the road. So by doing that again, you're making a far more properly illuminated crosswalk system to just increase pedestrian safety. So some of the common applications, of course, intersections, mid-block crosswalks, school zones, playgrounds, stadiums, airports, anytime you've got a pedestrian activated application. Some of the features, when it comes to activation, we will do all of the standard pedestrian push buttons. So that can be a standard Polara Bulldog or a Campbell. We can do all ADA compliant push buttons, for example, the Camel Guardian or the Polara INX. We can do the wave systems, and we can do passive activation as well. Each one of these products, because it needs to speak with its partner across the street, every one of these, like all of our crosswalk lighting systems, have built-in RF communication. So when one system is triggered, it immediately speaks to the adjacent unit to tell it that the system has been triggered. So we have built-in RF beacon-to-beacon connectivity with a range of just about 1,600 feet. The LED fixture, which we'll touch on a little bit later, is a very high performance, high efficacy LED floodlight, an LED Cobra head style streetlight. Also, these systems can and are designed to retrofit onto existing poles and structures. We simply need to know as much about that existing pole as is possible. So the pole thickness, the pole height, the outside diameter, all the basic specs of that pole is what we need to know. Simply because we need to make sure that if we're putting a large solar panel up on top of a pole, we need to make sure that pole is strong enough. For example, this would not typically be recommended for mounting onto a basic 2-inch Telspar square slotted post. Probably not a good idea, but typical traffic installations, not a problem. Also available, we do them in solar by default, but if somebody has utility power available, that's also not a problem. We can easily hook these up directly to the grid, or we can do a combination of a solar and a grid-powered hybrid system as we do with some of our existing JSF products. And last point here is they're actually highly customizable. So we can have these configured in just about any way the end user might want. We can do different lighting optics, which I'll touch on later, but we can do different colors. We can do different mounting schemes. We can obviously, as I mentioned, we can do different round beacon configurations, different RFB configurations, and different push button configurations. So they're quite customizable based on what the end user might like to see. Any questions thus far? Perfect, okay. So touching on the Lumiwalk LED fixture itself. This is a very high efficiency type of LED fixture it's a very sleek 4.7-inch wide LED, benefiting performance of the newest generation LEDs. The Lumiwalk, see if I can just move this for 1 second. The Lumiwalk 33-watt luminaire is absolutely perfectly suited for these types of applications because you're going to get, as you see here, you're going to get 133 lumens per watt. Now, if you're not in the lighting industry, that's okay. That might appear as Greek to you, what that number means. But 133 lumens per watt is actually a fairly efficient type of fixture. So what this means is this system is perfectly designed to give as much light on the ground as possible while consuming the least amount of energy. And anytime you're dealing with a solar LED type of application or product, that's key. Power is always key. So these tests you're seeing here, this is tested at 30 watts at 25 degrees C. So pretty much we're going to default, 9 times out of 10, we're going to default to a 4000 K, and that's referring to the color temperature, which is a fairly common color temperature. 4000 K and at about 133 lumens per watt, which means you're going to get over 4,000 lumens every time this light is activated at a crosswalk. And when you couple that with one light on one side of the street and another light on the other, I'm going to show you a photometric plot that shows you in 3D what that ends up looking like. So these can go as low as 2700 K, as high as 6,000. So if you have a customer that is very keen on a specific Kelvin color, light temperature color, we can likely achieve that. We just need to know in advance what they might be looking for. But this gives you a nice visual of the fixture itself with the mounting collar, all powder coated system, LED optics, just to give you a nice example of what they look like. Bear with me here, because I want to change slides. There we go. Okay, so digging a little bit more into the specifications here. This is strictly a DC fixture. Most LED fixtures you will find on the market are actually an AC fixture. Well, inherently they are a DC current inside, but they also have an AC driver that's going to put the 120 volts or the 240 volt, whatever the 270. That power is going to go into the driver, but it's always stepped down into DC current for the LEDs. Our system is strictly DC right out of the gate, so its efficiency is paramount. It's key. So we've got an input range of 11 to 20 volts. The brands we can use, this particular model is a brand called Hergy that we use, but in theory, if you have an application or a customer that is looking to use a specific fixture, we can very likely do that. We would simply ask for all the specifications on said fixture, what its operating voltage is, what its LED current is, all those variables, and then we can determine if that's going to work with our system. But ultimately, we are fixture agnostic, if you want to call it that. But we do default to this Hergy fixture you're seeing here, and what we're going to focus on today. So typically about 15 inches long, about 5 inches wide. That height's not quite accurate here because this collar is typically going to sit out to the side here. So it weighs about 5 pounds. It's a very small, very compact, very efficient fixture. IP67 rated. A pole mount is good for about 1.3 inches up to a 2.5 inch collar. It's a universal collar mount here. Operating window is significant. And it comes with a 10-year warranty, which is terrific. So most LEDs in the field are rated for 150,000 hours. So this fixture out of the gate is going to have a 10-year warranty, which is terrific. And this gives you some typical diagrams of an average configuration. So 9 times out of 10, let's take this as an example where you've got RFB light bars. A sign is this sign is here put here as a reference. Whether or not the system has a sign, these RFBs are going to face in the direction of the traffic. Therefore, at a 45-degree angle from this plane, you're going to have the floodlight facing directly out into the path the pedestrian is going to walk. So that's typically what you're going to see in most applications is this exact configuration, where you're going to have the LED fixture facing directly jutting out to the side. Here's an example to show it from a side view. Now, we can include a NEMA cabinet with these as well. Typically, it might be a 12 by 12 by 4. It might be a 16 by 16 by 4 or by 6. And what that's going to house is that can house the controller assembly and the radio, if the end user or the city wants to have it easily accessible right there. Otherwise, all of this equipment as well can easily fit up inside this enclosure here, where the batteries reside as well. So just to give you a basic example here, this will be the application, or I should say the configuration, 9 times out of 10. For most applications, this is what you'll see. The only variable, these could be round beacons. Maybe you'll have one beacon up here, one below, dual or single, whatever the application calls for. but this is a perfectly a common configuration of the system. So, touching briefly on the product range, for the Lumiwalk, in theory, we can have it any size solar that we want to see. However, for the ease of specification and the ease of purchasing and the ease of installation, we're going to narrow it to these 3 sizes. Now, ultimately, this is not something that you're going to need to memorize or worry about in too much detail. Once we have the particulars of the application and the project, we will be the ones that can help you determine what size is required. It's not something that you're going to need to focus too much on. So we've got a 70, 100, and 170 watt system. I happen to have a 70 watt right behind me. I've already run the numbers for the Pacific Northwest, and probably 90–95% of your applications in the Pacific Northwest will use this system, this 100 watt system, for almost all of your applications that would be focused on the Lumiwalk type product. The only time you're going to jump into a 170 is when you start going a little further north of the border into Canada. And the only time you're going to start to go potentially lower is if this happens to be in a fairly good solar location, but perhaps has very few activations. Maybe it's only going to be pushed maybe 100, 150 times a day, maybe 200. And if that's the case, we might be able to look towards the 70 watt unit. But as I mentioned, 9 times out of 10, this animal here, this 100 watt system is what you're going to be looking at. So now we don't have to go through this in too much detail, but this shows you physically what the systems look like when it comes to the solar and the battery package, the enclosure itself. So the 70 watt system, as I mentioned, that I have behind me, is typically 32.5 by about 23.7 inches. And if you look on the upper right, the 70 watt system defaults to a 3 battery array. So it has 3 batteries built in, and it has the energy management system. This diagram also is missing our controller in the picture. It's going to have a basic, our crosswalk radio controller. So this is actually going to have two small boxes along with the batteries inside this, what we call a pizza box type of enclosure. This is what we refer to almost as a superior view. This is what it's looking like almost from the top down, at slight angle of the system. And here's what it looks like from the side. And this is a large steel pie plate type of universal mount that's going to allow the end user or the installer to adjust this system all the way up to 60 degrees, from 0 to 60 degrees. So it's really nice where, depending on where it's going to be deployed, we can actually properly tilt that solar at the precise angle based on the latitude. So there's your 70 watt system. Here's your 100 watt system. So you notice the panel's now 32 by 6 by about 35.5. You're jumping up into a 6 battery array. You're going to have the same controllers built in, but it just shows you now you're starting to jump up in the solar, you're starting to jump up also in the battery side. Here's again the larger superior view, but again, it's using the same type of adjustable mounting collar that's going to go and tilt the solar from 0 to 60 degrees. And finally, we're jumping up into the largest one, the 170 watt system, which is 32.6 by 51. And it's funny, this footprint, I've been in the solar industry for about 21, almost 22 years, and a 32.6 inch by 51 inch would have easily been an 80 or even 100 watt panel a better part of 20 years ago. And now we're getting essentially more than double that wattage out of that same footprint, which is terrific. It just shows you the advancement in the efficiency of solar and PV systems in general. So again, 32.6 inches, 51.1 inches wide or long, I should say. Now we're jumping into a 10 battery array. Again, with the same controllers built in, it's just got a much larger system, larger battery, larger solar. There's your superior view, same mounting collar in a 0 to 60 degree increments. So now I'm going to touch on the photometric plots here, the photometric light calculations. So as I mentioned earlier, IES has a lighting requirement that they stipulate should be met at a 2-lane crosswalk when it comes to area lighting. And in a few slides ahead, I'm going to show you what that is, but it is a 20 lux average or a 2-foot candle average. And that is also measured at a 5-foot height. So that light is not what's shining on the actual concrete or what's on the ground, but it's actually what is measured at 5 feet off the ground. So JSF took the initiative to have a photometric study done, and we can do additional studies. They're actually not that difficult to do. So if you have a customer with an application that's very specific and maybe they want to see their own roadway layout done, we can actually do that. It's not very expensive to do. But ultimately what we did was we did this lighting calculation, and I can send this to you guys as well anytime. But this lighting calculation proves that we meet and actually far exceed the IES lighting recommendations with the Lumiwalk system. So this is just a typical example here of a 3D rendering. This is another angle of the 3D rendering. Now, this is what you see, what is actually hitting the ground, or what's in black. But the actual IES recommendation or requirement is what is 5 feet off the ground, as I mentioned. And this is the numbers that we actually want to focus on here. So again, this lighting study proves that we far exceed the IES lighting recommendations. Here is a superior view or a bird's eye view. And one thing to mention as well is this calculation was done with our Lumiwalk system at a 15-foot mounting height. Now, there is a bit of wiggle room as well with that 15 feet, where we could likely go as high as 18, maybe 19 feet. But the reason I mentioned the mounting height is we don't want to confuse this with a standard Cobra head AC powered that's sitting at 30 feet off the ground or 25 feet. This is a little bit different because it's solar. This is a little bit of a more purpose-built application design where we're going to have to change the mounting height and have it at a specific height onto the adjacent pole that's going to hold the push button and the RF beep or the beacons. Okay, so I just want to send that out as just a little tidbit of information that this is done at 15 feet. And one thing that you'll see here on the next slide, have a look at this slide very briefly. The next slide shows what it looks like as far as uniformity, as far as a heat map is concerned. Now, anyone in the lighting world, when you're looking at these photometric plots, this is a perfect indication to show you where there might be any hot spots. In other words, any issues in uniformity. And when you're looking at this particular example, the uniformity on this is very, very good, meaning that there's no dark spots. The light is consistent across the entire application. And that is part of the IES recommendations as well. But this light plot shows you how nicely uniform this setup actually is. From a two beacon setup, so we've got an LED fixture here, we've got an LED fixture here with terrific uniformity. And ultimately, these are the results that the calculation shows us. Again, unless you're familiar with IES or with lighting in general, this may appear as Greek, but that's okay. This shows us, here's our average that we need to meet as far as the spec for mixed vehicle and pedestrian, 20 lux or 2-foot candles. And here's what we're meeting here for the average lux. So we actually far exceed, and that's why I do say there's a little bit of wiggle room with that 15-foot mounting height. We can probably go as high as 18, maybe 19 feet, if that is, if that's desirable for the end user. Any questions on that? Okay. So this is critical too, and I know the guys at Coral are recording this session, but I will also PDF this PowerPoint, this slide pack. I will send it to them, and therefore they can pass the PDF version of this to you, so you guys can have it as a reference. Because this checklist here is really critical when it comes to the information that we need to see so that we can recommend the correct Lumiwalk for you. And this is very similar to all JSF products. And to specify our systems, we really need to determine these factors to provide a proper recommendation, be it a standard solar RFB, a round or dual round beacon setup, or a Lumiwalk. It's all quite universal. We need to know these details. So this checklist will allow us to specify the variables associated with any solar LED project, but specific to the Lumiwalk. So again, does each pole need to have single, dual, even quad, or single or dual RFBs? Is it going to be AC? So is there grid power available on one or both sides? And some applications, there might be power on one side of the street and none at the other. That's okay. We can have systems that will work for that application without question, no problem. So again, is it AC or is it solar? Has the pedestrian push button been determined? Because they have different power draws, a standard versus an ADA compliant or a wave. They need different power, so we need to know that. So is it going to be standard? Is it going to be a Campbell Guardian or an INX or a wave? Now, do we also know, or have we any idea of what the activations or the run times are going to be? For example, do we have an indication whether or not this crosswalk is going to be pushed 100 times a day, 150, 200, 300? And do they want to see 20 seconds worth of runtime each activation, maybe 30 seconds? Again, these are standard variables that we need to factor in for a typical crosswalk product. And is the area light needed for each pole with a beacon, or do they maybe want the lighting only on one side of the street? So if you can tell us that, beautiful. If you're not quite sure, we can make some assumptions. Is it going to retrofit to an existing pole, as we talked about earlier? And if it is, can you let us know what those pole specs would be? Because we need to assure the correct mount, the correct design, and to ensure that we can give proper recommendations for the correct pole size that should be used. And last, where is this physically going? We don't typically need to see the lat and long, the exact site, but if you can tell us the closest city or roughly where this is going, that tells us what we need to know as far as running the solar numbers to size the correct solar and battery for the systems. Okay, so now that's all I have for a slide pack, but what I'm going to do is I'm going to show you briefly, bear with me one sec here. This is the photometric plot that we did. And again, I can, with the PDF version of this slide pack, I can send this to you guys if you'd like to see it. So this shows all the information that anybody within the city, within the municipality, the state, if they're looking at photometrics, if they're looking at floodlighting, this is the information that they are going to want to see. And it's already been done for you, which is beautiful. So this is the full lighting calculation that was done for the Lumiwalk. This shows all the lux and lumen values on the ground and measured at 5 feet. So I'd be happy to send that along to you. And I'm going to share one more thing with you here.
There it is.
Beautiful. Okay, so again, I will send this along as well. Now, this is just a lot of technical data, but this is the system drawings and the system overview for the Lumiwalk. So we've got our battery capacity for the 70, for the 100, for the 170, depending on how many batteries the end user might want to see. Now, again, once we know the details from that checklist, we can make these recommendations. So ultimately, Coral or your customers and the end user, you're not going to need to try and wrap your head around exactly what should be used. We can help you without a doubt. We can help you with all of those recommendations and probably give you some options with it as well. So luminaire, this is the standard luminous flux or output for this Hergy fixture, but we can go up much higher with other third-party fixtures that we can use. It just talks about the enclosure, the weight, but also the EPA. This is something that pole suppliers are going to look at for when they're specifying the correct size pole for a new application. This is also what we look at when we're giving recommendations for retrofits, if there's already a pole on site. Because effectively, you're putting a potentially fairly large sail up on top of a pole. We need to know the EPA or the effective projected area of the surface when the wind is blowing. So we need to know how strong a pole needs to be to hold that EPA. Giving dimensions on pole recommendations. Now, this needs to be taken with a grain of salt, but we can help again. We can help with recommendations. System warranty, certifications, all completely UL listed equipment. And this just is a quick run through of all the systems it's compatible with. And the answer to that is effectively everything JSF manufactures, this can be compatible with. Okay, so I'm going to make a note to send this slide pack, the photometric plot, as well as this this data sheet off to you guys when we're done this call. Okay. So now, if anybody wants closer pictures, other than we've got in the spec sheets and that sort of thing, I'm happy to take much better close-ups of this. This is simply a not to scale demo that we have obviously here in our conference room. But ultimately it's showing a single black RFB, a 33-watt Hergy fixture, and a 70-watt system. Okay, so just like all of our standard equipment, the floodlight is going to come on only when the push button is activated. Okay, but that's effectively it. It is a standard RFB or a beacon system with the integration of a floodlight. Said floodlight comes on and then times out when the RFB does as well. It's very simple. It's very straightforward. That just gives you a visual idea of what the system looks like. Any questions there?
Not on my end.
So ultimately, if any of the viewers have any additional questions that come to mind after, by all means, Coral Sales is a terrific distributor for us, and I am more than happy to work with them to answer any of your questions. If you have any projects or you just have any general inquiries or you want to see additional data or information, I'm happy to help. I'm here to help them.
I have a question, Ron.
What's that?
I have a question for you.
Of course.
On a 4-lane road with a refuge island, have you looked at doing, I guess that would essentially need 4 of the solar LEDs?
You could most definitely do that. And so in the central pole, you would have 2 of these floodlights facing opposite directions. And we might, in that case, have to jump up to the 170-watt system, but it is absolutely doable. And in that case, that would have to happen to meet proper IES recommendations for both of those 2-lane streets.
Right.
But yes, that's a great question. Yep, doable, most definitely.
Yeah, because essentially with 4 lanes, if you have 2 lights in the center on both sides, then you're looking at basically 2 standard systems just doubled up. So your lighting thing would be the same.
Yep.
Some 2 lanes, just on center.
We would simply on the outside systems. This would be a 3-pole setup, right? So on the outside system, it could likely be a 70 or 100 watts on either side. But in the center, it would be the 100 or the 170 because we up the power because it's driving 2 fixtures simultaneously. But yes, it's not a problem to do that.
Awesome.
Yeah. Any other questions, thoughts, concerns, anecdotes?
I have one.
I'm on.
So do you have that IES file available if we want to check out the file ourselves in our lighting software?
Most definitely. I will include that with the email I send through to Coral Sales. No problem.
Cool, thank you.
Yeah.
Oh, no, I actually have that in a zip file that I can't open because I don't have the engineering software to look at IES, which I'm assuming you probably do. So I can definitely send that to you.
Excellent. Yes, if Mona is looking for that for her software, then she can open it. Most definitely.
I have a question as well.
Sure.
This is Tom over at ITD. So does the luminaire come on every time the RFB is activated, or is there a photocell option that it only comes on after dusk?
Yep, by default, it's going to come on whenever the push button is hit. If you wanted it to come on only at night, that's no problem, because the solar panel itself is acting as a photocell, because it's telling the system, anytime it detects voltage, the system knows that it's daytime. Anytime that it does not detect voltage, the system knows that it's nighttime. So we can do it either way for you without any question, without any problems. It's not hard to do that. But by default, it's going to come on anytime it's pushed.
Thank you.
No problem. Anyone else?
Is there a slip base on the pole?
Say again, sorry.
Is there a slip base on the pole for breakaway purposes?
Well, I should mention, we're not supplying the pole. We're only supplying the mounting collar that's going to affix to the pole. So in this case, no, there's definitely not a frangible or breakaway for this.
So maybe I can answer that as, we would typically, if you're looking at a certain slip base or a frangible breakaway, we would supply it. Like if it's in Washington, washed out state spec, we would supply, the break safe series or pull safe series to these poles for breakaways. So yeah, we're state specific, or whatever's on your QPL, we can definitely quote it the way your engineering specs show it.
Awesome, thanks, David.
You're welcome.
This is Ray again. Just wanted to see, I know that, we covered the Lumiwalk. Can you also just briefly talk about the area lighting option? Just a general overview on that.
Oh, absolutely. And, ultimately, guys, that could be a whole other discussion. So for the Lumiwalk, I literally kept it just focused on this, but absolutely. So with the area lighting system, what we can do is we can use this same fixture, and we can use other slightly larger fixtures as well. But if you take it away from the traffic side of things, and when somebody needs to light up a parking lot, a pathway, a bike path, any type of area lighting that's required where there's no utility power. So as we know, solar saves a tremendous amount of money instead of having to dig and trench power through the ground from point A to point B, especially if there's already concrete poured throughout the city or throughout the parking lot. So what I would suggest is if anybody's interested in that, and they have an application, like I mentioned, they want to light up an entire parking lot, or just maybe a dark corner of a parking lot, or the city they're with, or a customer of theirs has a green space, parks and rec applications, bike paths, walking paths, anything like that that needs light, but there's no power. Definitely reach out to us. We would then size and design the right solar, the right battery, and the right LED fixture in order to illuminate that area for the duration, however long per night the end user wants. Now that can be dusk till dawn, that could be sundown till midnight, and then maybe they want it off until the sun comes up. Maybe they want it to dim at 20 or 30% for the early hours of the morning and then come on an hour or two before sunrise. All different variables are easily done with our systems. We can do all those different, what we call operating profiles. So yeah, we have the ability to do remote LED solar area lighting systems where there's no utility power. Is that kind of a general rundown enough?
That was perfect.
Excellent. Yeah, we're happy to talk about that stuff too. And again, I mentioned we could do another coffee with Coral in regards to area lighting. So any additional questions with like that with that equipment, by all means reach out to me anytime.
All right. Are there any other questions?
No, I have one more.
Sure.
With the lighting power pattern that you have there, is there any issue with glare into the motorist eyes as this light is on?
No, good question. These are fully dark sky compliant. And it's typically what you may be alluding to, but no, these are designed to focus straight down onto the path only of the crosswalk and onto the pedestrian. The light spillage, or what's called light pollution, most fixtures that are certified, that are approved, that are sold in North America, have that taken care of, because ultimately, if light's being thrown where it's not needed, you're wasting energy, and that fixture is not as efficient as it could be. And the way that Philips and GE are designing all of their fixtures now to be as absolutely efficient as humanly possible, all that light spillage has been mitigated in one way, shape, or form, so that it's only focused exactly where it needs to be. This fixture is no different. So great question, Tom, but yeah, no, the traffic will be fine with light glare, most definitely.
Great. That was a really great question. Thank you, Tom. All right. If there are no other questions, we will go ahead and wrap this up. And yeah, I hope everyone has a wonderful day, and we will talk again soon.
Wonderful. Thanks so much, guys. I appreciate the opportunity.